Welcome to the deep dive. Today we're trying to answer something pretty interesting. How do we make learning robotics less theoretical and more, hands-on?
Right.
We've got some materials here about the R4 KC13 Plus kit from Polytech Educational Systems, mostly product info, software details.
Yeah.
And our mission, really, is to figure out what makes this kit specifically stand out for learning. What's unique?
Exactly. It's more than just, well, a box of parts, isn't it? And its heart, the R4 KC13 Plus, is this four-wheel drive robot
Okay.
combined with a mechanical arm.
Mm-hmm.
And this arm has 4 degrees of motion plus a grabber.
4 degrees.
Well,
But hold on, what does that mean practically, like for the arm?
good question. Think about how your own arm moves. You've got rotation at the shoulder, right? Bending at the elbow, wrist movement, and then gripping.
Gotcha.
This arm mimics that with 4 independent movements, so it gives you a decent range for picking things up, moving them around.
Okay, that makes sense.
Oh.
And the key learning part you were saying is controlling both,
Yeah.
the driving and the arm.
Precisely. Learning to coordinate those two things together. Imagine the tasks you could program if you can move and manipulate things at the same time.
Right, and it's all run by an Arduino controller, this ARD.icon thing.
Yeah, an Arduino ARD.icon microcontroller. Think of Arduino as like the brain. It's open architecture, so it's adaptable. It lets you tell the robot what to do.
And adaptable means you can potentially add more stuff later.
Exactly. Expandability seems key here.
Okay, and the programming itself.
Hmm.
The materials mention a tile-based GUI with icons.
Mm-hmm. That's a big plus for accessibility.
How so? Does it just make it easier for beginners?
Definitely. It lowers that initial barrier, Instead of getting stuck on tricky code syntax right away, learners can focus on the logic. They just drag and connect these visual blocks.
Like building with digital Legos for code.
Sort of, yeah. But what's clever is that it doesn't stop there. It also shows you the underlying C language code being generated.
Oh, interesting. So you can see the real code behind the blocks.
Right. It kind of provides a bridge. You can start visually, then transition to understanding text-based coding when you're ready.
That sounds like a really smart approach.
Yeah.
And it seems versatile, too. The notes mention obstacle avoidance, line tracking, even Bluetooth and infrared control. It's not just a one-trick pony.
Not at all. It's designed for various activities. Let's talk about the physical build for a sec.
Okay.
It uses high-strength acrylic for the base and the arm. Seems designed to be pretty robust for classroom use, easy to assemble.
Durable, yeah.
Yeah.
That's important. And you mentioned expandability. How does that work?
Through that ARD.icon controller, it has these RJ11 connections. They look like old-school phone jacks.
Okay, yeah.
You can easily plug in additional sensors or modules using those.
Simple enough. And power. Just AA batteries.
6LA batteries, yep. Pretty standard.
And the sensors it comes with. Seems like quite a few.
It does. You get ultrasonic. That's for distance sensing, seeing objects far away. Then infrared for closer obstacles.
Right.
Plus sensors to follow lines on the ground, detect color red, green, blue, and even sound and light sensors.
Wow. Okay, so it can react to quite a bit in its environment. And the arm motors.
4 servo motors included, specifically for the arm's 4 degrees of motion and the grabber.
So it really comes with everything you need to get started. Wheels, motors, base, arm parts, all those sensors.
The controller, Bluetooth unit, LEDs, motor driver board, even assembly tools. Yeah, it looks like a complete package out of the box.
Let's switch to the software again, that ARD.icon environment. You said
Yeah.
it's user-friendly?
Seems to be the goal. It uses open source libraries, which helps. And it has these pre-built driver libraries for the components.
Meaning you don't have to write code from scratch to control, say, the ultrasonic sensor.
Exactly. It simplifies things quite a bit. And that icon programming we talked about, the really neat part is seeing the block diagram and the actual Arduino C code side by side simultaneously.
In separate windows, yeah. That visual link must be powerful for learning.
Absolutely. It helps connect the abstract concept of coding with the concrete result.
And there's a simulation feature.
You can actually test your code in a virtual environment before you even build the robot or download the code to it.
So you can debug your logic first.
Right. See how the virtual robot behaves based on your code. It shows you the design, the function, helps catch errors early, encourages trying things out.
Less risk of crashing the real robot into a wall while testing.
Pretty much. Plus, there's real-time observation. When the physical robot is connected, you can see its status mirrored on the computer screen. The connected devices show up as icons. You see them working.
That's useful feedback. Can you see, like, sensor readings?
Yeah, you can view signal graphs over time or see instant analog and digital measurements. It allows for a deeper dive into what the robot is actually sensing and doing.
And it's all driven by this block language with icons. Makes it more engaging, I guess.
Seems like it. And multi-language support for the interface is mentioned too, which is always good.
Okay, what about the learning content?
Mm.
ARD.icon, EB, and CS.
Right. So ARD.icon EB seems to be the curriculum side. It's for self-paced or supervised learning.
Like lesson plans.
Sort of. It integrates training modules, theory, teacher aids, all in an ebook or e-course format. Uses HTML5, SCORM compatible, so it works with things like Moodle.
And it includes actual instructions.
Yeah, step-by-step guidance, theory notes, diagrams, the block code, the text code, and even video exercises with a STEM focus. Things like using the microphone, controlling the servo, signaling with sound and light.
And activities are provided.
Quite a few, actually. The notes mention 25 STEM activities for each high school grade level, though they are noted as being in Greek in the source material.
Okay. And ARD.icon CS. What's that?
That looks like the tool for the teacher, for creating databases of questions, making presentations, quizzes, monitoring how students are doing, analyzing results, generating reports, more of a classroom management system built around this.
Got it. So bringing it all together, what kind of stuff can students do with this R4 KC13 plus SFI? What activities really show off what you can learn?
Well, you could program specific arm movements, right? Like pick up an object and place it somewhere else.
Right.
Or use the sensors, maybe program it to find and collect only the red blocks in an area.
Using the color sensor, yeah.
Or navigate a maze using the ultrasonic or infrared sensors for obstacle avoidance. Follow a line on the floor. Control it remotely with your phone via Bluetooth.
Speed control, too.
Yeah, maybe make it slow down when it detects an object nearby. Explore basic smart car ideas, combining movement, sensing, and the arm manipulation. That's where the richer projects lie.
Okay, so summing up, the real strengths of this R4KC13 Plus kit seem to be.
I'd say the tight integration of the hardware and the software is key.
Right.
That user-friendly programming environment that cleverly bridges the visual blocks to the real text code, that's a big plus for learners at different levels.
Mm-hmm.
And then having those comprehensive educational resources built right in with that STEM focus, it provides a structured path for hands-on learning.
It definitely sounds like a well-thought-out system, a powerful tool. So here's something to think about.
Yeah.
How could a tool like this R4KC13, plus this blend of physical robotics you can touch and build, and this accessible, bridgeable programming, how could that actually shape the way we teach and learn STEM subjects in the future? Think about the kind of exploration and genuine discovery it might unlock for the next wave of engineers and programmers.
Yeah.
What doors does it open?
That's a great question to ponder. The potential impact of making these complex fields more tangible and, well, fun.
Indeed. Well, thanks for diving deep into this with us today.